Hi, my name is Jamie Muir. I'm with Redhook Supply in Waterloo, Ontario, Canada. In this video, I'm going to quickly discuss the components that make up a Weber automatic screwdriving system, as well as touch on some of the unique features that make Weber a leader in the automatic screwdriving market. So essentially, a Weber system is comprised of a controller, the torque tool, and the bowl feeder. Weber does offer a variety of different controllers. This one here is a very popular C30S controller. It does come with a 7-inch touchscreen. Which makes this guy great is that you don't need to bring a laptop to the unit to make programming changes. You don't need to buy auxiliary devices to unlock some of the functionality of the system. And you can also do all your changes directly on the touchscreen. For example, I want to change some of the parameter settings in my screw program. I can go to Screw Program, I can go Edit Program, and say, for example, I will change the speed. Right now it's set at 800 RPM. I'll make it 850 RPM, and it's simply that easy. So the unit itself will permit 31 unique programs to be housed within the system, accessed via your PLC or your controls. And it also offers 13 ready-to-go canned torque strategies. So a torque strategy would be something like one that's very popular is to drive to a specific depth, then tighten to torque while monitoring angle or the degrees of rotation of the fastener. Another one would be drive to torque while monitoring angle. And another one which is available would be to drive to a specific torque, rotate that fastener a certain number of degrees, and then retighten to a final torque before release. The system also will permit you to view the last 1,000 results. Very simply on the controller, it'll show you the results you got for torque, the time it took you to complete the cycle, the depth that you reached, as well as the status of the result, whether it was okay or not okay. If you're more inclined just to view the results that were not okay, there is a not okay button as well that'll show you just the last not okay cycles. Another feature we have as well on the system, if you want to take an existing program and copy it to an open or unused slot, one of those 31, you can do that very easily as well. You just have to go to Copy Program, find one of those open available slots, one of the 31, and insert the program, and you're done. If I want to be able to determine what changes have been made to a torque program, I can go to the logbook. This will be valuable for you if somebody made a change that you weren't informed of, that all the changes are located here. For example, we can see that I've copied a program. We can see that I've changed the speed in program 1 from 800 to 850. You can see there's all sorts of different program 6. The speed slope was changed as well. So that is literally that accessible. Then we move on to the actual screwdriver. So the controller is communicating with the servo motor and the angle encoder and the torque transducer. So you got the motor, the transducer, the internal bit stroke, and the tooling head. The one thing that's great about the Weber system as well is that when we drive a cycle, you notice the motor and the transducer all stays completely motionless while we're driving in the fastener. This is particularly useful. A lot of our competitor systems, there's a lot of motion during a drive cycle. There's a lot of fatigue placed on cabling, and as a consequence, with that fatigue, there's greater likelihood and greater frequency of requirement for cable replacement. This all stays completely stationary. The other thing to keep in mind too about the system is everything is modular. So for example, you had a problem that occurred in this component of the tool, you can simply take it out. It's simply that easy. If, for example, you needed to have your transducer calibrated, conventionally, you'd have to take the whole system out of production, have it sent away for calibration. With the Weber system, this transducer is just being held in by a union nut. You can literally take this off and then you can replace it with the backup transducer and continue to run production. The other thing to keep in mind as well with Weber screwdriving systems is that we can drive much shorter fasteners. So conventionally in our industry, we ask for the screw length be twice the screw head diameter. And the reason a lot of people need that is they don't have nearly precise feed tube. And the other reason is they have a tube that is welded essentially onto another tube that creates an elliptical shape where fasteners have a tendency to tumble. That's why they want you to have a longer fastener. What we do with our swivel arm, it's actually a tube inside of a tube. So we avoid creating that elliptical shape, avoid creating that tendency for fasteners to tumble, so we can actually drive much smaller fasteners. With regards to our feed tube, what we do is we take the diameter of the screw head, bring it to its closest millimeter and add 1. And that becomes the ID of the tube we select. So it allows us to drive much shorter fasteners. The swivel arm, which I mentioned, also permits us to dramatically reduce the cycle time it takes to complete a cycle. So conventionally, with a lot of automatic screwdriving systems, you'd wait for a completed cycle before instructing the system to send the next fastener to the tooling head. With the Weber system, we actually send a fastener to the head while the preceding screw is being driven in. The screw's being driven in, it sort of gets dead nested in the tooling head via the swivel arm. When that bit retracts, the swivel arm snaps into place and the bit is now seated inside the tooling head ready to go. Weber also offers a number of different nose pieces. This is a 3-finger nose piece, which is optimal because it gives you 3 points of contact on the fastener, so greater control. Say you had a screw hole location where there's a sidewall obstruction, you could use a conventional 2-finger nose piece. So if you needed to access a hole with a sidewall, this would be able to access that. Or if you had an assembly where the screw hole location is buried in a deep recess or hole, we'd be able to utilize a vacuum tube. The vacuum tube would travel with the bit internally, exit the tooling head, and be able to travel down deeply into that recessed space. So what we tell customers, if the fastener can fit in that space, we can probably assemble the screw for you properly. The other thing that we do, as I mentioned earlier, is we utilize depth. This is an analog depth sensor. It actually follows the bit as it travels internally in the tube. Because we know where this is located and we know where our part is located, we can guarantee that every fastener has been seated properly. So systems that are dependent on torque, angle, and time exclusively to determine a not okay or a bad part, we will also utilize depth. To illustrate that, I'll take a very small washer, very thin washer, that will give a torque result that would generally pass, an angle or degrees of rotation of the fastener that would generally pass, and time function that would generally pass, and our system will provide a not okay result. So we've got a not okay. If I go to my analysis screen, I look at my last results. I failed on depth, but if you look at the difference in torque, the preceding one was 0.8 newton meters and this one was 0.72. So a marginal difference in the torque that was achieved that would have passed all the other systems. However, we were able to detect it via utilizing our analog depth sensor. One of the advantages of the Weber automatic screwdriving system, how easy it is to change a bit. Bits are wear items. No matter whose system you're buying, you're gonna have to go in and change those bits. With Weber, changing a bit can be done in 30 seconds. Others, you've got to hit an e-stop, you've got to call the maintenance guy, he's got to go get his tools, he's got to come to the machine. It's all this elaborate work that needs to be done. With the Weber system, changing a bit is super easy. Other thing to keep in mind as well is this particular system that I'm showing is providing the Z stroke motion. It's got a cylinder that's riding on the back of another cylinder. If, however, you want to put this on, say, a 6-axis robot, and you're actually delivering the tool to the workpiece, and you don't require that, there are tools that are available as well that can be utilized without that additional cylinder, and these tools can work in any orientation. So it could be vertical down as well as vertical up or sideways. We're completely indifferent. So we've got the controller, we've got the actual torque tool, and then we move on to the vibratory ball. So Weber offers 3 different types. They offer vibratory ball feeders, they offer piezo feeders for very small fasteners and pins, very tiny stuff, and they offer step feeders. So this particular unit is a step feeder. Step feeder offers a number of advantages over a conventional vibratory bowl feeder. So a vibratory bowl feeder is the bowl that houses the fasteners is vibrating. So it's exposing those fasteners to a lot of vibration, a lot of jostling. So if you've got fasteners that have certain coatings like paraffin wax, some of that paraffin wax, those coatings will be removed. If you've got fasteners that have a cosmetic finish on the screw head, that cosmetic finish may be damaged. And the other thing to keep in mind as well is that the way a vibratory bowl feeder works is it is possible to have a fastener that spends weeks inside of a bowl, riding up onto the linear rail just to be discarded back in the bowl to continue to be exposed to all that vibration. In a step feeder, what houses the fasteners is completely inert, it doesn't move. What actuates the fasteners to travel up to the track to be escaped through our tube to our torque tool is a series of steps. You've got an electronic eye that determines that the track needs to be replenished and drop them on the rail where they're lined up to be escaped into the tube to the tooling head. The unit itself can also be emptied to the very last fastener. So vibratory bowl feeders require other fasteners present to help push those fasteners up the ramp onto the track. This guy can be emptied to the very last fastener. We also need to keep in mind as well that these steps can be programmed. So your PLC has control over when those steps are actuated. This helps reduce the amount of back pressure that is common in vibratory bowl feeders. Back pressure can create screw jams in the linear rail. Because we've got more control and there's less back pressure, there's decreased likelihood of fasteners being jammed in the linear rail itself. It's also very quiet relative to vibratory bowl feeders. You can conduct a conversation while the unit is running.